Multiplying rational expressions. Before we can look at multiplying rational expressions, we need to talk about what a rational expression is. We know about rational numbers. They can be written as fractions, a over b, where they're integers and the denominator isn't 0. So some examples of rational numbers are 2/5, -7/10, 153 over 22. Rational expressions are just polynomials written over each other. So instead of a over b, you can think of it as p of x over q of x. For example, 7 over 2x, x plus 5 over 3x minus 1, 4 over x squared minus 2x plus 1. So we know how to simplify rational numbers. We just look for factors. So if we have 100 over 75, we know 100 has a factor of 25 and 4, and 75 has factors 25 and 3. We don't have to reduce the 25s further because we know their factors match right here. And that will give us an opportunity to make a 1. 25 over 25 is just a 1. When multiplying, I can just multiply 1 times 4/3, which gives me 4/3. The same is true with rational expressions. I can simplify them by factoring out the greatest common factor. In the numerator, that would be a 5. So it's just 5 times, taking a 5 out of that x is an x plus 7. 5 out of the 35. If I were to distribute, I would get right back to that original polynomial. Same thing on the bottom. My greatest common factor is 4. So I factor out a 4. So I have 4 times the quantity x plus 7. Now I have an x plus 7 over an x plus 7. I have matching factors, and I can just make a 1. And so that would give me then 5/4 times 1, which is just 5/4. Now when you multiply, you do something like simplifying, because when you multiply a fraction, you're just multiplying the numerator of one times the numerator of the other, the denominator of one times the denominator of the other. So for example, if I have 18 over 35 times 14 over 15, I can simplify that. I can write it in terms of its factors. So instead of 18, I have a 3 times 6. Instead of 35, I have a 5 times 7. And that's multiplied by the factors of this fraction. So in my numerator, I have 7 times 2, which is 14, and 3 times 5. Now when I'm multiplying them all across, I can look for ones, even though they're in different fractions here, because when I multiply straight across. So here I have a 7 over a 7. That gives me a 1. I have a 3 over a 3. That gives me another 1. And I have 6 times 2 left on top, which is 12, and 5 times 5, which is equal to 25. Same thing with my rational expressions when I'm multiplying. These ones are already factored. If they weren't, you could go ahead and factor them, but I can look for common factors that are going to make a 1. Right here I see an x plus 1, and another x plus 1 right here. So that's going to give me a 1. X minus 2 and x minus 2. So 1 in the numerator, 1 in the denominator. When I multiply, that gives me a 1. I also have a 3, and inside 6 is a 2 and a 3 are factors. And so 3 and another 3 gives me a 1, and I have that 2 left over. Multiplying straight across, I don't have any other common factors. I have 2 times 2, which gives me 4. And I have x minus 1 in the denominator, so over x minus 1. So simplifying this after multiplying, I have 4 over x minus 1. Let's look at something that's a little bit more complicated. If we're going to simplify something like this. Now before we move on, I wanted to point out a couple of things you need to be careful of. So I know 16 over 16, that's equal to 1. That's also equal to 16 over 8 plus 8. Now it's very tempting to want to cancel the 8 and the 16, so to divide them both by 8. But if you did that, that is not equal to 2 8s. So if I would get 2 8s here, 1 is not the same thing as 2 8s. So you can't cancel when there's that plus sign in the middle. You must actually have a factor in order to cancel. You cannot do that. Same is true when you have a rational expression over a rational expression. Right here, you can't cancel the 4 and the 2a right here. You have to make sure that they're factors before you can cancel. So looking at this, if we have 3a cubed minus a to the fourth over 2a cubed minus 6a squared, you want to look to see if you can factor something out. So we're going to look up here. Our GCF, our greatest common factor of the numerator, is going to be a to the third. Both of those have factors of a to the third. So I'm going to factor out an a to the third. What I have left is just a 3 here. This divided by a to the 3 is just an a. So I have 3 minus a. I have a negative in there. In the denominator, my greatest common factor is 2a squared. So I have 2a squared, and I have left an a minus, we have negative 6a squared divided by 2a squared is just a 3. Now these look pretty close to each other. Notice they're additive inverses of each other. So if I can factor out a negative 1, they will look exactly like each other, and they'll be matching factors. So when you see something like this and they're reversed, you can simply factor out a negative 1. So if I factor out a negative 1 from this numerator, I still have my a cubed. Factored out a negative 1, if I were to distribute that negative 1, I would get right back up to here. That gives me a negative 3 plus an a. So that looks like this, it's just in the other order. And that's over still 2a squared times a minus 3. I can rewrite this with my a first, and I'm going to go ahead and take that negative 1 and multiply it by a cubed. So I have negative a cubed times a minus 3, I just rewrote this because of the commutative property of addition, over 2a squared times a minus 3. And the reason I manipulated it like that is because now I have a pretty fancy 1 right here. That just gives me a 1. And then I have a cubed over 2a squared. Properties of exponents. Oh, it's negative right here. Let's remember that negative. A cubed over a squared. When I divide those, I just have an a on top. So a squared over a squared plus an extra a in the numerator. And so when I multiply through, I have a negative a times 1, which is just negative a. And in the denominator, I just have my 2. So this simplifies into negative a over 2. That's a much simpler form than the above. When I'm multiplying, I can think about that same thing with my rational expressions. So I'll want to try and factor it as much as I can. First up, I can see I have a greatest common factor here and here. This term's all by itself, but I have another greatest common factor here. So rewriting, I can rewrite this by factoring out a 5. That's 5 times a squared minus 4 over factoring out a 2, 2 times a plus 1 times 4a, factoring out a 10, I have a 10 times an a minus 2. Well, I'm not seeing really any fancy ones. I can see the 2 and the 4. I can cancel some out there. I can find a fancy one. And the same is true right here. But I also see I can factor this. This is just a difference of squares. So a squared minus 4 factors into a plus 2, a minus 2. So I have the 5 times a plus 2, a minus 2, over 2 times a plus 1, times my same fraction I had before. Now I can see I have a common factor. I have an a minus 2 over an a minus 2. That's going to give me a fancy 1. And then I can go ahead and simplify here. The 5 and the 10, I can have a 5 over 5, which gives me a 1, and I have a 2 left in that denominator. The 2 and the 4, that gives me a 2. And the 2 and the 2, which gives me just a 1. Now looking at what I have left, I still have my a plus 2 times an a. So a times a plus 2, and usually it's written with the single a over here. You could write it over here and it'd still be mathematically correct, but that's just convention. Over, and I just have an a plus 1 times a 1 times 1, so all I have is a plus 1. So when I multiply these two expressions together, I end up with a times a plus 2 all over a plus 1. Let's look at a little bit more complicated one. So I have x cubed minus 27, and I'm recognizing that right now as a difference of cubes. So a difference of cubes is when you have two numbers and both of them are cubed. So 27 I know is 3 cubed. And then it's over this lovely thing down here. This I'm going to have to remember how to factor by grouping. So I can group the first two terms together and the second two terms together. So terms 1 and 2 are grouped together and terms 3 and 4 are grouped together. This doesn't factor. This is a sum of cubes and it doesn't factor. This also is not factorable. So let's see where that leads us. Factoring a difference of cubes, I just have x minus 3, this to the first power minus this to the first power, x squared, and then I'm going to combine the x and the 3 and take the opposite, is plus 3x, and then I take 3 squared, the second one squared, which is going to be a plus 9. And that's all over. Now factoring this by grouping, I'm going to take the greatest common factor of the first two terms, which is x squared, and then I get x minus 3, plus I'm going to take the greatest common factor of the terms 3 and 4 right here, and so I factor out a 4, and I have 4 times x minus 3, and that's handy. That's exactly what I wanted, because now I have this matching term right here that I can factor out. So I'm going to factor the x minus 3 out of both of those terms. So factoring out an x minus 3, I have an x squared plus 4 left. Now notice if I were to distribute the x minus 3 times x squared, I would get back here, plus 4 times x minus 3, I get right back up to here. So this is factoring by grouping, and this is a difference of cubes. So those are two different factoring techniques you've used before, but now we're using them to multiply these rational expressions. Now, it's handy because I see that x squared plus 4 here and an x squared plus 4 here. They're both factors. So I can make a very fancy one here. I'm seeing a very fancy one here too, x minus 3 over x minus 3. That gives me a 1. And then this is also a factor. I have x squared plus 3x plus 9 over x squared plus 3x plus 9. That's also going to give me a 1. And what I end up with is just a 1 times a 1 times a 1, which is 1, over 1 times 1 times 1, which is 1. So 1 over 1 is just 1. So this multiplied together just gives me a 1. Now when we divide fractions, we use the same techniques as if we were dividing rational numbers. So dividing our numbers right here, I'm just going to rewrite it as a multiplication problem with the reciprocal of that second fraction. So I rewrote the first fraction times and took the reciprocal, I just flipped that up there, took the reciprocal. Now I can go ahead and multiply, but first I'm going to look for some 1s in there to make my life a little bit easier. So I see the 15 and the 5, I can make a 1 out of the 5s and then have a 3 left in the denominator. And the 2 and the 8, I can use 2 over 2 and have a 4 left in the numerator. And I have x here, and I have an x squared here. So dividing, I have an x on top and a 1 on the bottom. So x squared over x is just going to be an x. I have a squared here and an a here. So dividing, I'm going to have 1a left here, and that's a 1. Y squared and y, 1, and then I'm going to have a y left in the denominator. And b over, I think this is supposed to be b to the 4th. Let's say that's b to the 4th. B to the 4th over b is going to leave me with b to the 3rd. Okay, and you can see I see that b to the 3rd right there. So then multiplying through, now that I've simplified it as much as I can by finding those 1s, I have a 4 times x times b cubed, which I'm just going to write as 4b cubed x. Usually I go in alphabetical order, so I do that b cubed first. And then on the bottom, in the denominator, I have a 3 times a times y, so 3ay. So I simplified first, and then I multiplied. If you wanted to, you could multiply all of this and then simplify. I could say that that is 40 x squared y a b to the 4th. And then I could do the same thing down here and multiply through, and then go ahead and find my 1s. I just find it's a lot simpler if I do it like this. I have less, my numbers aren't as big. So same with this one. When we're looking at multiplying or dividing, we want to simplify and factor it as much as we can because we're trying to find those ones to make our life easier. We can actually multiply it all through if we wanted to and then try and factor it. But it's easier if we can find our ones. So leave the first fraction and you're going to flip that second fraction and multiply. So we turn this division problem into a multiplication problem, just like we do with our rational fractions. So I have x plus 4, factoring this. I have x plus 4 times x minus 2, multiplying together to give you negative 8, adding together to give you a positive 2. The bottom one, going ahead and factoring that, I have x plus 3, x minus 1, multiplying to give you 3, adding together to give you that 4x. And then this one, I factored out, I flipped the fraction and then factored out a 3. That's the greatest common factor here. So that's just 3 times x plus 1, and then x minus 2. Now I can see I have some common factors in my numerator and denominator, so I'm going to see if I can make some fancy ones. So I have x minus 2 over x minus 2, and that's just going to give me a 1. And I have x plus 1 over x plus 1, and that's going to give me a 1. And then I have left 3 times x plus 4. 3 times x plus 4, and in the denominator I have x plus 3. And I've got it.